Good morning, everyone. And I hope for everyone it is audible. On behalf of pantechelearning, happy Sunday to all. I sincerely thank Professor V. Swaminathan sir, HOD of E&I, providing this wonderful opportunity to conduct SLAM robotics. Also, I thank Dr. T. Lakshmibai ma'am, Assistant Professor, Dr. T. Sundar sir, Assistant Professor. Once again, I thank management of Sri Chandrasekhara Saraswati Vishwa Mahavidyalaya College, Kanjipuram, for providing this wonderful opportunity to conduct the SLAM robotics. So based on this particular SLAM robotics only, we can also relate towards our autonomous vehicle, which is one of the leading technology inside the robotics. And I welcome all participants, those who have joined this particular session with their keen interest. So now let us start the session. Okay. So whenever you are getting towards robotics, so SLAM robotics, how that particular kind of interface is being worked. So what and all that particular components we have used for SLAM robotics, and we will be seeing just a demo video. So how the SLAM robotics is working by interfacing with MATLAB using UDP protocol. So whenever we just work regarding towards this kind of SLAM robotics, the another kind of name it is known as TurtleBot. So how that particular robot named it as TurtleBot means based on its particular appearance as well as its particular functions. Because how the turtle will be moving means it will be moving in a slow way by checking in front of its obstacles and all not. Any predators are there or where is the particular sea. So based on that only it will be moving on. The same way only here we are also moving our robot with the help of LiDAR. So LiDAR is the most important component whatever we are using inside this particular kind of robot. So LiDAR it is nothing but light amplified detection and ranging. So based on that particular light, it will be rotating in the 360-degree format. So from the 360-degree format, it will be passing out all the light. So based on that particular wherever it is just hitting that particular light and receiving back. So based on that, the detection range is also calculated, and therefore they will be able to obtain the distance, and at the same time they will also able to map. So that particular mapping it is nothing but here it is creating the self distance and which path it should move to avoid the collision. So this kind of functions only here we will be able to implement inside this particular SLAM robot. So the SLAM it is also known as automatic navigation. So here we must use some sort of embedded system family, like to monitor the particular mapping. Here we have to use our Raspberry Pi as the controller. So here we will be integrating that particular LiDAR directly towards a Raspberry Pi, and from that particular Raspberry Pi it will be able to get all the mapping values which is done in 360-degree, and that particular mapping values here we will be transferring it to the MATLAB software into the system. So through UDP protocol. UDP is nothing but user datagram protocol. So from that user datagram protocol, whatever the values it has been received, automatically the MATLAB creates a 2D map. So once whenever we start that particular video, you will be able to see how that mapping is done. So therefore that particular 2D map will be created according to the obstacles whatever it is present inside that particular area or the room whichever we are going to leave the robot to move. So in that particular space, now we will be thinking, so how that particular Raspberry Pi is able to work with this lidar. So for that, here we have to just apply the one of the important operating system known as robotic operating system, ROS. So for ROS, we have special Ubuntu OS. So inside that particular Ubuntu OS, here we will be able to read all the data whichever we are capturing from the lidar. So all that particular reading or getting that particular simulation or that 3D view, everything we will be able to acquire and see it in that particular Raspberry Pi. So through that only we will be acquiring that entire data. So once after that acquired data through UDP, we will be transferring to the MATLAB. So here inside the MATLAB, it will create a 2D map. So therefore the mapping has been completed inside the robot. Now according to the map, here we also have to make that particular robot move. So therefore once whenever the obstacle is being matched from that particular robot, so here we will be using Arduino as the controller. So through that particular Arduino, therefore we will be able to control the motors either to move forward, backward, left side, right side, or we have to stop the robot. So in between, here we are using another one, a kind of module also known as Bluetooth module HC05. So that particular HC05, here we have to integrate between our system as well as the Arduino. So based on the mapping directions, here we will be able to instruct that particular robot either to move forward or move diagonally or move left side or turn 360-degree. So like the kind of some instructions we will be able to provide according to the mapped value. So this particular abbreviation of SLAM, it is nothing but simultaneous localization and mapping. So here what and all we are going to localize means we are going to localize all the objects and we are going to map the entire room. So once whenever we are just going for this kind of autonomous vehicle, definitely the mapping is also taken and at the same time localization of pedestrians is also taken over there. For example, the driverless cars, what and all the controls required means the steering control, gear control and vehicle movement control. So these three controls should be taken according to the location and obstacles. So in that particular cars, here we have two different kinds of inputs. One is the LiDAR and another one is camera. So with the help of LiDAR, we will be able to detect the surroundings, which is around of 20 or 30 meters. So within more than 30 meters also it is possible. So within that particular range, here we will be able to detect that particular area and map it, what and all the obstacles are there. But with the help of LiDAR, we won't be able to detect what is that particular obstacle. Okay, so that much amount of deep learning or machine learning still not yet created. So that is the reason they have just implemented the camera to just detect the obstacle whatever it is in front of the car. So that particular camera will be fixed in front of the car only. So therefore if any pedestrians or any animals they are crossing the roads or walking in between that roads, therefore that particular cars will be automatically slowed down, and at the same time through that particular camera it is also able to measure the speed of the car which is moving in front of them. So therefore they will be integrating this camera, LiDAR, and LiDAR is also being applied in the form of 360-degree as well as the straight vision. So from this particular two integrations will be directly provided to the processor and controller, and the controlling is provided directly to the automatic gearbox and at the same time steering. So based on the steering, the vehicle controlling also will be done. So here the wheel drive, for that particular drive also we will be integrating with the controller, so that the braking as well as accelerating purpose will be automatically provided. So in this way only the SLAM robot is completely related towards this autonomous car. So once whenever we are going on this kind of SLAM robot other than the autonomous car means, we can use it for some of the delivery oriented purpose. So some robots like which has been implemented in some of the hotels, they will be using this kind of lidar based robot also to map that particular entire area and predefine that particular map inside the robot. So therefore for delivery purpose, like delivering the food or getting back that particular delivered plates or glasses like that, so for that kind of purpose and all we can use in as a short distribution manner. So for that also we can use this kind of lidar based robot. So once whenever we are working this kind of lidar, the most powerful lidar it is nothing but RP lidar, which collects the data of 360 degree, whereas the lowest range of
see a calendar setup. Want me to send a link to your phone to set up your calendar?
sorry, there was an interruption over there. So once whenever we are working regarding towards this lidar, the lowest application of lidar is nothing but TF mini lidar. So inside lidar itself we have three different variations, like the straight view, 0 to 180 degree and 0 to 360 degree. So this is nothing but the particular block diagram where we will be integrating our SLAM robot. So here you can see just the Raspberry Pi is connected towards the RP lidar using USB serial, and that particular Raspberry Pi is directly connected towards a power supply to enable that particular UDP section, and from that we will be just integrating directly towards MATLAB inside our system, or we can also directly transfer the data into our mobile. Then we will be just going on with the Arduino part, the robotics part. So here we are connecting HC05 to Arduino and Arduino to motor driver, and from there robot chases with wheels. The motor driver is connected with 9-volt battery. So to enable this particular kind of function in an complete wireless manner, we have used power bank as a power supply for both the Arduino as well as Raspberry Pi. So these are the list of hardwares required for that. So inside this particular Raspberry Pi controller, here why we are not able to directly connect that particular motor over there means, so inside that particular Ubuntu OS or the ROS OS, they are not providing the particular supply for GPIO pins. So that is the reason we are taking an additional support of the controller. So by using this particular controller here, we will be able to just collect all the datas. So collecting the datas in the sense, through USB serial communication, the RP lidar starts to rotate, and based on that particular kind of each and every implementations or each and every kinds of obstacles, whichever it is found in and around that particular environment. So that particular data, it is taken in the form of values. So that values are nothing but axis. So what is that particular axis value means? At which place that particular light is being sent and received. So that particular axis only here we will be able to calculate, because inside that particular RP lidar also we have some sort of processor which process the data and converts into serial. And a DC motor with L29 3D driver. It is known for everyone. That is nothing but a H-bridge motor which has capability of connecting two motors and therefore we will be providing that particular input pin, and from that particular input pins there will be 4 pins from Arduino, and that particular 4 pins indicates each and every direction of motor. So 2 pins equal to function of single motor only. So in that particular ratio only we will be connecting the pins. So after providing that enable of 5 volt and the power supply external of 9 volt, therefore it will be able to obtain in the rated speed. So therefore, based on the message whatever it has been received from that particular MATLAB software whichever we are using in our system, the controller decides a particular direction, and therefore motor will be energizing this particular supply. So to get the rated speed of motor, we have to provide at least 9 volt or 12 volt. So that for that particular reason only here we are using our motor driver. So if you guys have any doubts regarding this, you can just post it. So guys, if you like this video, just click on like, and if you want to share this video to any of your friends, those who are interested to work with robotics, you can share with them. And if you are new to our channel, you can subscribe our channel. So I hope for everyone it is clear regarding towards till whatever I have explained. So in MATLAB, they are also providing some of the simulations for ROS. So now let us just have a look on that. So kindly wait for some time. Let us open the MATLAB. So to work on this particular ROS based simulations means you have to install at least 2018. So just we are waiting for our MATLAB. So in meantime, if you guys have any doubts, you can just post it in chat. We hope that you guys are staying safe. So during this pandemic period, please be careful and be safe. Be safe at your home. Yeah, definitely we'll be sharing the PPT. Okay. So here we have some basic applications for autonomous functions in MATLAB. So that particular functions are available inside the add-ons. So here we have to select that required tool. So these are that particular important toolbox that should be implemented inside our system. So I hope this takes a while. So through this only we will be able to simulate that particular automatic parking system. So this is done with the normal camera based images. Yeah, due to the software issue, it is not able to collect the data. Sorry for that. Okay, so let us directly move for the video. So here we can see that this is known as that particular RP lidar. So this particular RP lidar is connected towards the Raspberry Pi, and below Raspberry Pi we have kept the power bank to provide the power supply, and these are the DC gear motors. And above this DC gear motor only, here we have fixed Arduino to control that particular motors. So now let us see it's working. So now for that particular implementation, to collect the data or to collect that particular map, we are using this particular program. So by clicking on each and every GUI, it will be moving from one portion to another portion, and therefore here we will be able to get the data of 360 degree. So whatever you can see that particular pink lines, those are nothing but the obstacles. The blue line, it is nothing but it's moving. So it's from starting point to currently the live session wherever it is moving on. So once that particular obstacle is about to detect, we can just provide it to left or right. This is just to train that particular MATLAB. Like this is the map. This process is called as mapping process. So now the obstacle is detected. So once that obstacle is being detected means here you can see how much thick line we are able to get inside the map. Here we won't allow this particular robot to move as fast as possible, because all the movements will be done in a slow manner. And here maximum we will be using that 100 rpm robot, 100 rpm motors. So this is just its explanation.
Hello guys, welcome to pantechsolutions. Today we are going to see the project called Path Planning Robot using RP LiDAR with Raspberry Pi, which is booted by the ROS using MATLAB. Let's go for the hardware explanation. So here we are having a robot setup, a very tiny robot setup. So for that we are using a Raspberry Pi 3 Model B. So in this Raspberry Pi 3 Model B, we booted ROS for controlling this robotic car, and we are having this RP LiDAR, which is RP LiDAR model A1. And for controlling this robotic car setup, inside we are having another controller, which is Arduino Uno here we are used. And then below the Raspberry Pi, having power bank for giving the supply for both Arduino as well as RP LiDAR, so that to control robotic car, we are 9-volt battery, which is already present inside here. Let's go for the demo now.
So using IP address, now we are connecting our UDP section. So here we will be taking our Raspberry Pi's IP. So finally, the path of the particular robot is also created. by using the same lidar, the self-driving robot which I have explained to you. So this is the most application that has been implemented using Raspberry Pi.
Move on, autonomous car version 2. This version 2 car contains two modes. One is human follower by using deep learning with camera, and second one is path planning using RP lidar. So for that we are using Raspberry Pi 3 Model B and then toggle switch.
And so to download that particular ROS OS, it is open source OS only. So we can move into that ros.org. So here we can download our required kind of function. So mostly we will be using this ROS noetic NIGEMS. So this will be the particular operating system which we will be implementing for our kinds of robotic purpose. So if you guys are interested, you can also work on it. So this is free and open source. You can directly log into ROS website and you can download it. So guys, if you have any downloads, you can just post it. If you have any doubts regarding this robotic operating system as well as lidar, you can just post it over here. And there is no such software which we will be able to simulate this particular lidar other than MATLAB in our system. And at the same time, if you go with Raspberry Pi, you have to go with ROS operating system only. Normal Linux OS won't be able to support, and still many of them are trying to bring that particular ROS implementation into Python. So I hope soon it will be happening. Yeah, MATLAB 2018, at least it is required, but it would be good if you are just upgrading your MATLAB versions. So the real-time application of this particular robot, it is nothing but self-driving cars, which has been created by Tesla. So inside that particular Tesla's visualization itself, they have that particular lidar visualization. And this is mostly used for obstacle avoidance. So any doubts or any queries regarding this particular session, you can just post it in chat. I hope all the participants have received their attendance link in the description box. Yeah, so thank you for your wonderful comment, Victor Benevent Raj. Thank you for your wonderful comment. So if you guys have any doubt regarding this, you can just post in comment. So these are the particular end results on working with complete mapping. Yes, MATLAB is completely used in over here. So MATLAB here we are implementing in two different network connections. One is for IoT based UDP to receive the data from Raspberry Pi, and another one is Bluetooth module connection to connect from MATLAB to Arduino. So these are the two functions that is done using MATLAB in this particular implementation. And definitely you can just follow us on Instagram, WhatsApp, and Telegram also. Also, you guys can just follow us on pantechelearning.com. So we are conducting regular events. If you guys are interested, you can just log into the webinars or learnathon or free workshops. We are also providing the certificate training in the banner of IETE as well as NITK step training for multiple technologies and multiple durations. And if you are interested to work with many of your projects on your own, so you can also purchase the kits, do it yourself during the lockdown. So based on that particular webinars which we are conducting, so with that webinars you can also integrate your own creativity towards the products. And for more details, you can ping to our web-based WhatsApp. Why didn't you use C? It's so easy compared to the MATLAB. This is my opinion. Please explain yourself. This question is asked by Adimulam Udayachandran sir. Definitely, inside MATLAB also the particular coding is based on object-oriented programming. So MATLAB, it is nothing but a universal tool which can be applied for multiple applications at a single time. So whatever we are using inside the Raspberry Pi for this ROS, it is only for the purpose of receiving the LiDAR data. So there is no any particular separate coding which is available for that. So here we have to receive the data, and according to the data, the localization and mapping should be created in the form of visualization. So while compared to other programming languages, MATLAB is better in that visualization. After collecting that particular data, we have to transfer that particular data through Bluetooth towards Arduino. So that is the main reason here we are using this MATLAB. While compared to other programming tools or softwares, MATLAB has interconnectivity between all the technologies. And a very nice question, Adimulam sir. I'm expecting more questions like this. Okay, guys. Thanks for your wonderful support for today's webinar. And I hope everyone is happy regarding this particular kinds of knowledge sharing. So how that particular RP LiDAR is working and what are the different projects, and from where we can collect the OS for this particular ROS system, and how the MATLAB is used for this particular dual interconnectivity for UDP as well as Bluetooth module. Okay, guys, thank you all. And during this pandemic period, stay home, stay safe. For further details, you can contact us through pantechelearning.com. Thank you all.